Hey everyone, this is Coach Graber. I'm here to talk about metacognition in the math classroom and how you can approach problems thinking about your thinking. So, again, metacognition means that you're being aware of your thinking processes, you're thinking about how you're approaching tasks in math. So, there's basically two ways you can approach a problem like this. These are type of activities we'll explore in math class. You can just start typing in numbers and see what happens. Say type in 4. When you're asked to explain your thinking here, like, why did I choose 4? Like, I just guessed 4. There's no reason for it. What I want you to start working to do instead of just guessing or trying things, because this is not going to work, but to think about what's happening here. What's this showing? What's this trying to depict? Think about how you're going to approach this and what does this actually mean. So this is showing some sort of balance here. It says not balanced, and we want to try and balance this. We have see an 8 on this side and a 3 on this side. So we have to ask ourselves, what are we trying to find here? What does this x depict? We want this to be balanced. We want these to be the same. So we have to ask ourselves, okay, what would this x be then? Well, we know that 5 and 3 makes 8. So let's try doing 5 and see what happens. So that works there. And then make sure you're actually thinking through what you're doing, explaining why. So you can say 5, 3 is equal to 8. But it's really important to make sure that you're stressing the thinking. So why do you do it? How does it work? Why does it work that way? Let's look at another one. So this one here is saying, okay, now we have the balanced hanger here, but what math is happening here? Are we saying that there is 3 times x is 8? Or x divided by 3 is 8? Or x plus 3 is 8? Or x minus 3 is 8? So again, you're thinking through what's actually happening here and how this actually works. I want you to be thinking about your thinking, how you see it, how it works. So this is saying x and 3 together, which is an addition. So think about how the math connects to the visual. Here's another one here. Now, what is this showing? Think through what is happening here. What's the visual? How does it work mathematically? So this time we see 2 of these pentagons is 12. So if 2 pentagons is 12, what would 1 pentagon be? So in this case here, I would say it's 6 because each pentagon together has to equal 12. So that's what I'm looking for, is for you to be thinking through your thinking, evaluating why it works, how it works, and checking the visuals that you see with the actual math that you're working on. Let's look at a more difficult one. That one's pretty easy. Okay, now here we have one that has some graphing involved. There's an algebraic equation here. So again, here, you may not know how this works. You may be very confused by it, or you may know how it works because you've seen it before, but let's say you don't. You want to get this line to pass between these two blue points. Now, naturally, you're going to start playing around with these numbers, right? Let's say we change 2 to 3. What's different here? What I want you to think about is not just trying numbers until it hits the blue dot. Like, I can do that. I can just keep on doing numbers until it hits the dot. 6, 0.7, 7, 0.4, 0.5, and eventually I'll get one that hits the dot. But instead of doing that, I want you to think about how does this number affect the graph? That's the metacognition, is thinking through why is it working the way it does. So if I look at this graph here, and I see a 2 here, I want to think about, where do I see 2 in the graph? So looking at the graph here, where do I see 2? Well, there's a couple places you might think about 2. You look at boxes up or boxes over. If you go 2 boxes over, you see the line up here, so that would be 4. Doesn't make a lot of sense there. But if you go 1 box over, and then it goes up 2. So let's check out that one. Let's change it to 3. So 3 would means if you went 1 box over, it goes up 3. Hey, that actually works. So 4 means you go one box over, up 4. So now this time I'm going to go over 4 boxes and up 2. So I have to think about what number I could put here. So if it goes over 4, it goes up 2. Well, if I can eyeball it, so 4 up 2, but if I go back to 1 box, it would be somewhere around a half a box. So I'm going to try putting a half in. Boom, it goes over 1 box, goes up a half, and then that keeps going and hits that dot there. So think about how you're approaching this. That's what I want you to do. That's what I'm asking you to do in math classes, thinking about how changing these numbers actually affects the graph, how it actually changes the math, and think about why. Well, what math is happening here? This is actually multiplication. So that's saying you're taking the x number, which is this number down here, and you're multiplying by this number here to get the y number, which is the up and down. So I'm taking 4, which is the x number, multiply it by half, 4 times a half, or 4 divided by 2 would give me 2, which is the y number here. I know it could be confusing at first, but start thinking about how are you approaching the task? How does this make sense? And make sure that you're making actual sense of it. So think about that and think about how you can get better at exploring math, understanding math, instead of just doing math. And that's the difference. That's what I'm asking you to do this year. I promise you'll do well at math this year if you're understanding it and you're trying your best and you're asking questions. Everyone does well in my class if they do those things, if they're trying their best, asking questions, getting help when they need it. So that's all I have for today. Take care. Have a great day.